A very good evening, sir. I, Ravi Kumar,
And I am Niranjan Kumar Chauhan.
will be presenting on laser communication system. Next slide. The aim, the aim of this project is to design a communication system through a laser diode at the transmitting end, act as a transducer to convert the digital data into laser form and transmit it at the receiving end. A laser transistor convert the data into digital form. Here the motive of using laser is that while the transmitter and receiver must inquire line-of-sight conditions, they have a benefit of eliminating the need for broadcasting rights and buried cables. Laser communication systems can be easily deployed since they are inexpensive, small, low power, and do not require any radio interference study.
Introduction. So, the laser communication systems are wireless connections through the atmosphere. They work similarly to fiber optic links, except the beam is transmitted through free space. They have the benefit of eliminating the need for broadcast rights and buried cables. Laser communication systems can be easily deployed since they are inexpensive, small, low power, and do not require any radio interference studies. The carrier used for the transmission signal is typically generated by a laser diode. Two parallel beams are needed, one for transmission and one for reception. Due to some restrictions, the system implemented in this project is only one way.
So this project is a microcontroller-based laser communication system used for successful transmission of data. In this project, using two microcontrollers, we are transmitting data from one end using laser transmitter and at other end received by laser receiver, which is connected to the pin of microcontroller. Here the transmitted as well as receiver data is displayed on the LCD.
Approach. So these are the platform that we have used: microcontroller 889C51, LDR, LM7805, regulator, power supply, resistors, capacitors, transistors, liquid crystal display, transformers, connectors, laser transmitter, laser receiver switch. Power supply section consists of RLMT connector. It is a connector used to connect the step-down transformer to the bridge rectifier. Bridge rectifier, it is a full wave rectifier used to convert AC into DC. 9 to 15 volt AC made by transformers is converted into DC with the help of rectifier.
Capacitor, it is an electrolytic capacitor of rating 1000 mAh/35 volt used to remove the ripples. Capacitor is the component used to pass the AC and block the DC. Regulator LM7805 is used to give a fixed 5 volt regulated supply. Capacitor, it is again an electrolytic capacitor. 10 M/65 volt is used for filtering to give pure DC. And capacitor, it is a ceramic capacitor this time to use to remove the spikes generated when the frequency is high. So the output of the supply section is 5 volt regulated DC.
LCD, liquid crystal display. Microcontroller based LCD display. This project is an embedded project. Embedded is the combination of software and hardware. Before designing any embedded project, it is the first step to design the proper hardware for the desired application. Here we are interfacing the LCD liquid crystal display with the microcontroller. We are using ATMEL series 51 controller, 89C51 controller. It is a 40-pin IC. The first step while designing hardware is to design the required power supply, as the controller operates on plus 5 volt supply. So first we have to design the regulated supply with the help of transformer, regulator and filtering capacitor. Next step is the necessary connection of the controller like reset and the crystal oscillator for resetting and speed respectively.
So now I will be telling the working of the project. So there are two microcontroller, one at sending end and the other at the receiving end. Laser transmitter is connected to the pin of the microcontroller at the sending end, and the laser receiver is connected to the microcontroller at receiver end. When a person is wishing to send the data, the microcontroller make the laser transmitter to send the frequency corresponding to the data, and at receiver end that frequency can change to the original data from which will display on the LCD connected to the pin of the microcontroller. In this way, the function of the transmitting the data through laser receiver and transmitter have been completed.
We have three sections here: supply section, display section using LCD, communication, and here in between there is a microcontroller and it is connected with a transmitter which contains the laser diode. Transmitter is an electronic device which produces radio waves with an antenna. The transmitter itself generates a radio frequency alternating current which is applied to the antenna.
In receiver section, we have supply section, microcontroller 89C51, and a display section using LCD. A receiver has two main functions. Firstly, it amplifies the sound so it can be fed to your speakers. And secondly, it allows you to select the audio in which you wish to watch.
Statement of research problems. So, the laser data transfer is used to transfer the data successfully via two microcontrollers while displaying the data. Using the LCD screen, so anywhere where data is to be transferred, we can use this technology. But due to its range limitation, we cannot send the data for a long range. Only when receiver and transmitter are close to each other, then only data can be transmitted. The systems are protocol transparent, allowing transmission of digital computer data, LAN interconnect, video and voice over IP, multiplex data or ATM. They are suitable for temporary connectivity needs such as at conventions, sporting events, corporate and university campuses, disaster scenes or military operations.
The conclusion of our project is that it gave us understanding of microcontroller and made us realize the power of microcontroller and help us understand how to use the laser. The project has achieved its set target well in time and budget based on the cutting edge technology called embedded development, which is niche in the market today and its future is much bright. The product must develop is ready for implementation and bring financial benefits through by sale in market.
So these are the references that we have used, and we would like to thank and conclude our presentation. Thank you.
Thank you, sir.